Okay, let's do these last two questions. All right, so here we go. Last three questions. Knowing his initial velocity, okay, from problem 9, and that he reached a height of 42 meters, how long did it take him? So you calculated his initial velocity here in 9, which should have been around 4.69 or something like that. Okay. Now use his average velocity and the acceleration for, then take the average velocity times the time, and that should equal the time it took him to get to his maximum height. So on question 10, so what are we doing here? On question 10, mystery question, all right. So on question 10, what we're doing is we're getting LeBron from here up to here. We're figuring that time. Well, what goes up must come down in the same time. Okay? So you're going to figure this time using his average speed, okay, times the time is equal to that 1.1 meters. So you calculate his average speed and you get T is equal to 1.1 divided by that average time. All right? And then to get his total in 11, to get his hang time, you take that answer and you go, oh, multiply it by 2. I don't mean to like tell you how to suck eggs or anything like that, but if you're brand new to this stuff, this shit's hard, you know? And there's all these little things you got to think about and all this stuff. So I apologize if it seems like I'm babying you or something like that. But I want you to have fun. I want you to see how we do science, how we think, and the little mathy things that we do, and the reasoning that we go through. Okay? So let's go on to the last problem here. It says, for LeBron, we're going to look at the change in momentum. Ooh, this will be fun. So in problem 12, we change momentum to calculate the force, massive force he pushed off with. If he was in, remember, Skywalker was 9G, so we're going to see what LeBron's thing was too. If he was in contact with the floor for 0.05 seconds, and his initial velocity was 0, and his final velocity was what we computed up here in chapter in problem 8, okay, or problem 9. Where did we? In problem 5? Where did we? Oh, yeah. We found his, yeah. We found, yeah, problem 9. I'm sorry, I lose my mind every once. Plus I'm sick. Give me a break. All right. So yeah. So we from problem 9, you calculated that. That will be his final velocity as he pushes off from the floor. Okay? And so what does all this mean? This looks really crazy. All right? So let's walk through it. Let's use our handy dandy ladybug, paid for with your tuition dollars. So we're talking about the impulse that's going to hit him. And that's the average force. That's what we're after. Times that change in time is equal to that change in momentum. And we learned earlier in the course that momentum is equal to mass times velocity. And so his change in momentum is his final momentum minus his initial momentum, which his initial momentum was equal to 0. All right? So we know this. We know that the F times 0.05 is equal to 114, that's his mass, times that answer we got in problem 9. Okay. Oh! So to find what's the only thing we don't know? Well, we found this in problem 9. This is the only thing we don't know. Well, that's pretty easy. So we take the force that he feels is equal to 114 times that velocity from problem 9 divided by 0.05. And it's pretty big. It's a massive amount of force. And if you calculate, it comes out to be about 9 Gs. If you divide out his 114 kilograms and take what that acceleration is. Then you're left, and so the force, the acceleration, then, and that's what they're talking about when you see the people in the movie, in the science videos, they got accelerometers. That's what they're calculating, is the acceleration. And so that's the 9G thing. And I think it comes out to be pretty darn close to 9Gs. Okay? All right, have fun with this. It's been a fun semester. It's been interesting. I hope you learned something. I hope you liked it. It's a lot of work to make it good, I think. And so I don't want to work at it that hard, so it sucked. No, I worked pretty good at it. But anyway, hope you enjoyed the course. And for those of you that are business majors or something like that, and you want to dip your toe further into science, there's some astronomy courses that are a lot of fun at the 100 level that don't require, or not even business, but any of you out there that are a lot of fun that shows physics on a grand scale, out in the universe scale. So it's because physics goes from the very, very dinky to the universe. Anyway, good luck on your finals, and I will talk to you later. I'll probably talk to quite a few of you when you start saying, hey, could you open up assignment so-and-so?